carrier package unit, air conditioner. Okay, here's the basics of it. 24 volts gets made here in this transformer. There's a 5 amp fuse. It's a self-tripping. If something shorts out, if this shuts off because it grounds out, this is going to click over and it's going to be a white or red dot. You'll reset it and it'll reset. A low voltage short is going to end up there. If this shuts off, your thermostat downstairs is going to stop working. This sends 24 volts to the board. Okay, the board sends that 24 volts down through the red, so the power is coming to the board, and then it is leaving on the red only. It is heading downstairs to the thermostat, which is then saying what needs to happen. So I need to turn on the blower fan. Green is always the blower fan. Y1 is always cooling. Y2 is always heating. That's universal. So if we need the fan on, and only the fan on, that 24 volts that left on the red is going to come back on the green, and that fan is going to start kicking. If the cooling needs to happen, Y1, the system's going to send 24 volts up on green and yellow, because while yellow or white, heating or cooling is happening, if we don't have the blower fan, you don't have anything. So that's going to kick up. When yellow starts, both the compressor and the condenser fan. So there's your condenser fan, and your compressor is in there as well. We'll open that up and look. As far as green goes, if you were to test voltage and say, all right, so see if we can do this one-handed here. Red to common, right? Common's like your neutral. 1 second here. All right, we have red to common. We have 24 volts. If we have green to common, 24 volts, and the fan is spinning. We go yellow to common, we have 24 volts. So we're cooling. If we were to check W, right, to common, we got nothing, because we're not heating right now. So if the compressor wasn't running and the condenser fan weren't running, so when it energizes W or green, what it does is it sends the 24 volts then over here to these contactors, and it pulls them in. Okay, so those are pulled in, and the units are running right now. If you test Y1 to common, right, we're cooling, and we have 24 volts, but the contactor isn't pulled in, it's because that 24 volts isn't getting there for a reason. So, let me grab my insulated here. So when it leaves Y1 on the board, right, internally, to head its journey over to start the compressor, it goes out this LPS. This is a low pressure sensor. That 24 volts goes out to the low pressure sensor, and if that low pressure sensor says we have enough pressure to run, it comes back. Then it jumps through the board to the high pressure sensor, goes out, comes back. Once it's back from here, then it actually gets sent out one of these browns over here to the coil, and that pulls in. So when you have a blower fan spinning, but you don't have the compressor and the condenser, you can chase down Y before you do anything with your gauges. Electronically, how far is your signal going? Check here to common for 24 volts. I check this to common. Hey, I have 24 out. Boom, I have 24 back. Okay, I have 24 out. I got nothing coming back. I know my problem is either that the high pressure switch is open and not allowing that signal to come back, or I've got a problem in the wiring between here and there. So let me show you a little more what that looks like. All right, so I've powered down the unit. So this is the condenser fan and the compressor area. I'm looking at, actually looks like there's oil on this, like there was a Freon leak, but here nor there right now. This is what I want to explain to you. So the large pipe is cold. It's the suction line. It's the Freon coming back. This is your low pressure sensor, and we just talked about that, right? So 24 volts is coming in and leaving. If this isn't above a certain threshold, then it doesn't allow it to run. If we burst the copper pipe and all the Freon blew out of this, you know, the pressure would drop, much like blood pressure, right? It would just bleed out, there would be no more blood pressure. If there is no pressure in here, it's gonna say, hey, I'm not gonna let you run. The thermostat is going to think it's running. So inside it has a little snowflake. If you checked it, you've got 24 volts at the yellow cooling terminal, but nothing's coming on because it's off on low pressure. Conversely, if this is the high pressure sensor right here, a small line, really hot, coming out of the compressor, it's measuring that. If the head pressure gets out of line, if this condenser fan locks up and stops cooling the Freon, then that head pressure is going to go crazy high. And to keep the pressure from becoming destructive, that says, hey, no good, shut it down. So these are unfortunate versions because they're torched in. So, you know, if this high head pressure sensor fails, there are alternative ways to do it. But, you know, ideally, you've got to, you know, recover the charge, pull this out, torch a new one in, you know, pull a vacuum, new charge. There are ones you can add on to the Schraders, to where you can add a pressure sensor on there. But again, we'll talk about that another time. I just wanted to show you the actual pressure sensors and what that means. This is the blower assembly, motor and housing, right? So when it energizes green, it pulls in the contactor, and then that starts this spinning. So we want to check that these belts aren't shredded up, that these aren't full of debris and gross. There's actually a piece of paper that got sucked in there. I talked about when the transformer trips, if there's a low voltage short. So here's what I mean by that. A lot of these are low voltage wires running over to various sensors. So if this, we see this is a previous rub out. That is where wires rubbed until it made contact. Fortunately, if it's a low voltage short, it'll just make contact, it'll short out, it'll trip that little breaker. If it is a, you know, full on 120 volts, then it's gonna trip, it's either gonna blow a fuse or it's gonna trip a big breaker downstairs. More than likely it blows the fuses. So it's a different story if you have no power anywhere. You know, then there's no sense in checking to see, oh, do I have power at yellow or green? No, you don't even have power at red, there's no power. So, I mean, I didn't start at the beginning to say, hey, you know what? This main block here, that's your power coming in. If I want to check if I have power, I can do it right at the south terminals of that. Yes, 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 we're good. So, yeah, there is that. These are the heaters. So this specific unit is electric heat. So there are contactors inside of here. And if you can see, there's like little, you know, power in, power out. So when those contactors pull in, there are two heating elements. So this is spinning, blowing, pulling air across the coil, down and out. When the heating element is blowing air in from the building and then out across the heaters. So let's talk about the refrigeration cycle for a second. All right, so the compressor just started. So let's walk through this real quick. You got your compressor right there. The compressor is taking the Freon in the system and it is compressing it. High pressure, vaporized, right? So it takes that hot gas and it starts passing it around and around this coil. Now this coil is, you know, there, and then it actually, not only does it go there, but it wraps around that side as well, just that corner. So back and forth, back and forth, back and forth, back and forth. So what's happening is it's taking the ambient air outside, which, you know, today it's beautiful, it's like 70. It's taking the 120 degree air temperature vapor that it's putting out, right? And it's cooling it. So it's taking our 70 degree air, it's dragging it across that burning hot Freon, and it's actually liquefying it. So it saturates and it turns into a very high pressure still, but it's a liquid. Then that liquid runs behind, and in that process is where your high pressure sensor is. So once it's a liquid, it runs behind into what was this coil. I'm going to show you this again. Right? So that coil right there is the evaporator. As it enters the evaporator, there are a lot of little tubes. And those little tubes, little copper tubes, they have a metering device in it. It's a little fixed orifice device, right? So the tube is this big, and then there's just this little tiny orifice. And what happens in refrigeration is pressure equals temperature. When it slows down the pressure by pinching it off, the temperature dives. So you have a high pressure liquid, was a vapor, cooled to a liquid. Now it hits those, those orifices, and they choke down. Now it's a low pressure liquid, right? And it just drops to, 40 degrees. So now you're probably in the 80s coming through. Now you're 40. Well, the blower is pulling air through that 40 degree coil. So it's drawing its air from downstairs. So it's coming up on the other side of the coil, coming through the coil. So now you got 70 degree, 80 degree air coming up from the kitchen through the 40 degree coil, and then in the blower and back out. That's how we're making 55 degree air inside. Okay? So the Freon is running through there, actually starting at the bottom this time, but it's a liquid. And so as it goes through and it fills that up, and we drag that 75 degree air across it, it boils and it vaporizes, and then it runs back through the backside and back into the compressor, right? So that's the entire cycle. Then it just does it again. So it leaves the compressor hot, saturates it, hits the evaporator, chokes it down, then boils off in the evaporator till it's nothing but a vapor, comes back to the compressor, high pressure all over again. That's the cycle. So that is the basics of refrigeration as Joe understands it. There's a lot I don't, understand. We're learning together in all these videos. I just trying to pass along the things I've come across here and there. Just so you can get the complete picture here. So this is the other side of the evaporator coil. So this is the return coming up from inside the dining room, running through my coils, which those are day 27. So they're actually about 5 days overdue to be changed, which you can really tell. If you pull that out and hold it up to the sun, not a whole lot of airflow getting through there. So we're going to do a PM on this unit tomorrow. I just wanted you to see more of the big picture. Okay, sometimes from a troubleshooting perspective, also I want you to see this contactor. So we'll talk about having to test something and jumping it out. So you remember I talked about my 24 volts is leaving red. Well, right now my blower's spinning, but my cooling isn't running. It's not supposed to be running. It's satisfied right now. But so if I put half of my jumper on red, it's 24 volts. I mean, I'm touching it right now. It's not zapping me. So we're dealing with 24 volts. But when I clamp this on to yellow, even when I just touch it, right, it starts. But there's a really interesting thing, and I don't know if the camera's going to catch it. When I jump this, watch the contactor pull in. Didn't really see it that time. There's an arcing that's happening. I don't know if you can see that burn mark. Right? Look at how nice and clean the one on the right is. And look at how burnt the one on the left is. But when we talk about jumping out something, I could take this clip, I could just clip it on Y1, and now I've got it running so I can diagnose and not have to worry about running downstairs. I actually can control the temperature from the phone, so I very seldom have to jump things out, but you don't just want to jump something out unless you know what's going on a little bit, because if something's off on low pressure and that's why it's not running, and then you force it to run, you can obviously do damage to things. But that is probably the wrap up of kind of carrier unit basics.